Next on the list, oh geez, I need to figure out all these acronyms. We have a topic, achieving a high degree of interoperability between data spaces, APIs, and components which use NGSI-LD, OGC, and IFC models or services. So with me, we have three people. Frédéric, that you know from yesterday, president of Youragileway. We have Michael Mulquin. Well, you are asking the questions already, huh? So I don't think I have to introduce you. And Jean Brangé, president of AFNeT services. Thank you, and I think we're taking this to a different level because so far we have been talking about how to connect to data spaces, and now we're talking about a little bit more how to connect data spaces in between.
I guess.
Yes? Perfect.
Within data space.
Okay, so you got 3 microphones over there.
Okay. So
take it away.
Fine. So I'm starting, I guess. I guess we need to. Oh, which way around is? Oh, here we are. Good. Just to go back. So, oops. Already starting with a crash. So I'm really your warm-up man. I'm here to set the context. The really important people are Frédéric and Jean to give the real detail, the nitty-gritty stuff that's useful and practical. But from my perspective, so I work with Open and Agile Smart Cities, which is an international city network, which is strong in Europe. And for instance, in Europe, our link is that we've been leading the European Commission-funded data space for smart cities and communities. We read the CSA, and we're now leading the deployment phase. So we're really interested in data spaces at that kind of level. And of course, the issue is that cities are collecting lots of data is being collected within cities by city administrations themselves, but also by many other different agencies in the city. And many different kinds of data is really important for cities. Building information modeling data, GIS, context data, social media data, qualitative, mobility data. So there's all sorts of data being collected within cities that are really important to help understand and help manage cities better. The challenge is that each of these different types of data is structured in a way to provide insights within a particular context. And so it's absolutely an enormous task to try and align these so that we can start to get the insights that cities need to be able to manage the city better. I think somebody somewhere once said that data doesn't flow in rainbows, it flows in services. I seem to have heard that somewhere. I mean, the key issue here is that actually it's services that are focused on use cases. Cities, other agencies, we've got things we need data for, and we need to find ways of aligning these different sorts of data to get those insights. So today we're going to be concentrating on 3 particular families of standards. There are many others. NGSI-LD, and these are enormously inaccurate stereotypes or high-level pictures, but please forgive me for not getting it perfect. But NGSI-LD was developed by Fireware and standardized by ETSI to bring context to sensor data. So originally, this is very much focused on IoT. It's grown and expanded, but that's the idea of NGSI-LD. Geospatial standards are being developed by the Open Geospatial Consortium and others, but that's kind of the most authoritative standards body. And that's really focused on how we can describe precisely locations, areas, movements, things like that. And then Building Smart International is developing lots of standards which are being standardized through ISO and other agencies too, but are developing standards to help manage building and construction, how you describe the different aspects that are needed to make an office block, a home, a bridge, and how can you make sure that you can use that data to help manage the whole process of constructing those different parts of urban infrastructure and managing them long term. So there are 3 really important families of standards. So all of them are in some way or other, there are many other things that are common, but all of them are handling at least these same 3 sets of issues because you have to. You can't be effective if you don't. So all of them know they need to have a way of describing locations and movements. All of them know that you need to be able to bring data about urban infrastructure. If you're going to use data in the city, you need to be able to manage context, positioning, and so on around buildings, roads, and bridges. And they're all trying to work together to think about how to link different sources together to provide insight. The challenge is that, of course, because they have a different focus, each of them has different strengths and weaknesses around those different issues. So for instance, and again, this is an enormously inaccurate stereotype, but if I were NGSI-LD is particularly good at enabling IoT data to be linked with valuable context data. It's no good knowing this is data from sensor 532. I need to know, that sensor on air quality is located near this busy road junction, or is located near a factory, or is located near a hospital. And so it's really important to be able to provide rich and effective context data to all of that. It can handle geospatial and building data, but only at a certain level, because that's not its main focus. OGC standards, enormous rich families of standards, which are really about handling all sorts of data about, as I say, movements, locations, shapes, and so on. But they can only provide a certain amount of data around, or facilities around how you manage context and building-related information. And similarly, BIM and IFC standards are brilliant about construction, design, and all the rest of it, but that's their focus, and the other aspects they're not so strong on. So what we're talking about here is how we can bring some kind of interoperability between these different families of standards in order that cities can use the relevant data that's being captured by each of these different sorts of data sources to enable them to understand what's happening in the city and what they need to do about it. So they don't need to get all the information from OGC standards and all the information from NGSI-LD and all the information from IFC and BIM standards. They just need specific pieces of information related to specific use cases. They need workarounds to help them be able to fairly quickly, with a minimal amount of effort, be able to utilize all these different sorts of data and bring them together. And that's the kind of thing that we're looking at in our Open and Agile Smart Cities minimal interoperability mechanisms. We've got a number there: context, data models, contracts, trust, transparency, security, places. So a number of things that we're working on. Many of them are already being deployed, but we're continuing to develop them further. And what we're trying to do is to understand what the key challenges are in each of these specific areas we're looking at, and to understand what different sets of standards or approaches there are that cities are using to capture those different issues, and then to understand how to bring as good as possible interoperability between them so that you can actually take data from these different standards and bring them together easily. And recognizing that plug-and-play interoperability between these standards is impossible. And in a way, you don't need to attempt it because they're trying to do different things by and large. What you need is ways to start to align them. So the kind of things, these are just examples. If you can align the data models that are being used that are interesting to you, that are coming from OGC and from NGSI-LD, that's a good first step. If you can make sure that all the data is using common identifiers for things, so you know absolutely that you're talking about the same thing, that's another step. And there are other things. And what we're trying to do generally is to identify what these different things are. Now, thankfully, we've been given this little bit of funding from ETSI, and this is brilliant because ETSI is very well aware of this issue. It needs to develop and grow in order to be able to more easily address these sorts of issues. So we've been given some funding to try and identify what the priorities of cities are in using geospatial data, and therefore working with ETSI to help them understand what sort of modifications, additions need to be made to their family of requirements around NGSI-LD to help it to more easily address that. And interestingly enough, OGC is also looking at proof of concepts around how to link data models from from the OGC perspective with the Smart Data Models initiative that is linked to FIWARE and NGSI-LD. So we're really happy to be in the middle of this, and what you're going to have over the next few minutes is a deep dive into some of these sorts of issues and how we can start to tackle them. And I'm going to hand over to Frédéric here. Thank you very much.
Thank you, Michael. First of all, something happened to me. I'd like to position NGSI-LD vis-à-vis that DSCC building blocks. I would say that NGSI-LD is more about data models and also data exchange, though it does not cover all the dimensions of data exchange, especially on the control plane. But before I go more in detail into NGSI-LD, I'd like to do a first comment. First of all, it's probably a standard that matters to the Gaia-X community because NGSI-LD is very central to FIWARE. And as you know, FIWARE, IDSA, and Gaia-X all belong to the Data Space Business Alliance. So there is some important work here in terms of interoperability. And I would ask a first question, who knows or has heard about NGSI-LD in that room? I'm asking the question because it will, if there are not many, I will spend more time on it, and I will spend less time if many people know. So please raise your hand. So not many people know that standard. Basically, the idea of NGSI-LD is to have three levels of modeling. The first level is called the meta model level. Basically, it's a way of describing the world using concepts that most of you know, entity, property, and relationships. I'm not going to go into the detail explaining what's an entity relationship model, but let's say that you create entity instances, for instance, an instance of vehicle, and that way you can, in a JSON data structure, say that entity, which is an instance, that car is of type vehicle, and you can describe its property and its relationship. For instance, here you've got a relationship, that car is parked on an off-street parking and probably at some location. So that's the idea of the meta model. Of course, you see that behind that, you've got a domain model. A domain model is specific to a domain which is many times a business domain. For instance, you represent the fact that you've got vehicles which are parked on off-street parking, and you also know that that off-street parking has, for instance, a camera. That domain model, in a city, you can imagine there are many domain models. So one interesting question is, what's the scope of the standardization on the HC side? The HC side standardize the meta model. It standardize what we'll talk about, which are the cross-domain model ontology, but it does not standardize the specific domain models. And there are many domain models that could be standardized, and it's an alliance with FIWARE and other parties known under the name Smart Data Models that standardize those data models, but it's not HC. Now the cross-domain model ontology, let's say that the idea is that because you have so many domain models, many property, for instance, such as location, will be developed in each domain model or many of them. So the idea is to could standardize them, for instance, geoproperty, language property. I mean, how do you translate the name of an property from one language to the other? And very importantly, temporal property, which means that you can represent time, which is extremely important for representing domain events. I'm not going to cover all the cross-domain model ontology properties, but let's say that in the work we do for HC, we are looking at expanding those cross-domain properties. Now let's dive into the two other standards that Michael talked about. The first is CityGML. And it's just a subset of the class hierarchy of that standard. You see that if I take the concept of building, it's deep into the class hierarchy, because it's somehow a subtype of feature, which itself is subtype of another geographical object. So you see that it's a different way of representing a specific domain model. And it can be also translated into a simpler form, which is CityJSON. And here you see that you've got objects such as bridge, building, building parts, building story, that would all belong to the domain model level. Now let's look at the third standard Michael talked about, which is the IFC standard, which we find in construction for doing building information modeling. Here you see that we are also talking about story, building, site, but it's in different hierarchy. And there is an ISO report that looked at the incompatibility between the two standards, and basically they listed several incompatibilities. So we see that IFC can also be modeled at the domain model level, but both models are not compatible. And the mapping that are done essentially is work at the domain model level. But now let's take some higher view of that situation, and especially on the multiplicity of the domain model that we find in a city, but it would be true in any large domain. The idea is that, and it comes from domain-driven design, which actually is now very popular in the area of software engineering. Eric Evans wrote in 2003 that if you try to combine multiple domains on a large initiative project, the code that will result will be buggy, difficult to understand, and it will yield very bad outcomes. So his recommendation is to explicitly define the context in which a model applies. So in a city, if you are more working on the building side, maybe you should use the domain model that is appropriate for doing that. If you are looking more at the geographical aspect of the city, maybe it would be better to use a geographical model. And there are also questions of culture and also teams, because you have teams in cities that are very geographical oriented, and what's the point of trying to make them think with other representation and the same way around? And if we go a little further, we see that in the area of data and data spaces and data, I mean, these are two important subjects. The data mesh concept is becoming extremely popular. Actually, in one of the versions of the architecture document, data mesh are explicitly referred to. And the idea of data mesh is decentralization and distribution of data responsibility, and to the people who are closer to that data. So we see that both approach advocate not the unification of the models, but different models in different concepts that work together. But you might wonder, hey, if I have all those different models, how can we make them interpret? And here, Eric Evan has developed what was called context map patterns, which are integration patterns. Those patterns were also further documented in the Open Agile architecture standard developed by the Open Group. And in those patterns, I would focus on two important patterns. Event publisher, meaning that if you want to have integration between loosely coupled domain models, for instance, a BIM model, BIM domain or geofield domain, you can communicate through events. And instead of also trying to cast one entire model into the other one, you can use anti-corruption layer, which means translating concept from one domain to the other domain. So how does it work? And I think an example makes it easier to understand. Here we have a parking operation domain that actually reuses one of the smart domain model, smart data model that Fireware has developed. So it's about running the parking from the perspective of the parking operator. You've got a second domain, which is a geographical model where they focus on, for instance, a live flood map where they can send alerts when there is a risk of flooding in some area. And you've got a smart building domain, which actually is based on the AFC, but with other components, for instance, IoT and so forth. And here, the type of cooperation you can have when a car enters into the parking, the parking operation domain can send a domain event saying the car that enters will go to floor 4. We've seen that the concept of floor probably corresponds to the concept of building story of the AFC. So the anti-corruption layer can translate one into the other. So from the smart building domain, you don't have to learn the vocabulary of the parking operation domain. You can work within the concept of your domain. Same thing for the geographical model. The live flood map can say, hey, there is a flooding risk of a water body. And we see that the OGC supports the publish and subscribe pattern, and also the probably the smart building domain can also support it. So when there is a flooding risk of that nature, the event can be sent to the smart building model to avoid a situation such as the one that happened in Houston. A poor lady was trapped in a parking after a very big thunderstorm, and the elevator was blocked. So the smart building domain itself can prevent that from happening and also send an event to another domain to alert local authorities. So we see that by combining those two patterns, we can keep each domain model in its own context and still have integration and interoperability between those contexts or domains. If we do that, what's important is to link the object that belong to different contexts. We've seen that the car was going to floor -4. What's important, even though the floor number -4 is represented differently in two different models, it is the same domain object. So it's the same real-world object. And if we do that, then we can really establish relationship where we can trace the life of real-world object instance during all its life cycle. And now I'm going to go back to the cross-domain ontology and ask Jean to talk about coordinate reference and location and other.
Yes, thank you. That's the answer. So, why are we looking at this? I will show you two examples of data and how data is represented. And in fact, why is it important? Because we have to look at the data quality. Data quality encompasses a lot of properties and qualifiers, and precision, for example, is one of them. And we know that in fact, so we are looking at the location. So the location in the NGSI-LD, for example, and in the OGC API is defined, and there's a default representation for this location, which is a set of coordinates. Very easy, that's not difficult. It just happened that in OGC, the default is to use a coordinate system, which is WGS84 for longitude and latitude. And this is an American standard, so its reference is in the USA. It's not in Europe. And the OGC allows the people to use different reference systems. That's very important because different people may have different way of representing the same data. And the OGC standard also allows people to convert from one reference system to the other reference system. You can do this as long as you know in which reference system you are working. And in fact, in Europe, the directives are not to use the WGS84 reference system, but to use a European reference system, which is in fact the ETR S89. And this system is different, what does it mean? It means that in fact, the two sets of coordinates do not represent the same point if you're in the two different reference systems. There is a slight difference between the distance, which is defined by this same two set of this couple of numbers. It may not be dangerous. It may be dangerous because it could be 5 centimeters, could be a little bit more. You can be on one side of the wall, on the other side of the wall. You can be in the fire or outside of the fire, safe, depending on which reference system you're using. So we look at that as an example, and we just discovered that in fact today NGSI-LD did not explicitly include the reference system in their coordinate systems for the geospatial. They consider that it's maybe a default. It's not a big issue because we can, first thing we are going to do is to check with the smart cities which ones they are really using in practice, in reality. And then we'll be looking at making a recommendation maybe to the NGSI-LD so that the reference system could become a mandatory attribute of the location instead of just being not defined, because this could maybe save lives. So this is what we are going to do on this topic. And in fact, the other standard, the AFC, also have a reference system. So we can, all these reference systems are ready to be used, but in fact, they are sometimes omitted or people just don't look at it. But I guess many of you have already made the difference that when they get if you're using on your phone and you want to copy-paste your geographic reference system, you may end up with different places, depending if you have a Google or an Apple or a Samsung. How is it that with the same set of numbers, I don't get the same position, location on my phone? That's part of it, because they are not based on the same reference system. So it's important to get the data and the reference for which you are working on your data at the same time, because that's one of the topic. So that's something we're doing. Oh, next. The other topic we have been looking at is the level of details. So that's very important in geographic systems, and it's very important in construction, in the construction. Unfortunately, same issue. The OGC level of details are not defined exactly the same way as other people are defining level of details. So in the OGC standards, we have 4 levels of details, which are related to the geometry, visualization, and refinement, so that you can, when you zoom, you can have a better representation of your systems. And OGC works, CTGML defines 4 levels. In the construction industry, you can use much more level. The numbering is going from 0 to 500 with increments of hundreds, but you can decompose of increments of tens to answer the process in the building industry where you define the level of detail of the information you need to share with your partners when you are designing or constructing or in operation, and this level of details are not the same. And another topic that is coming from the construction industry is the standard which is called LOIN. So the level of information needs. This is coming from the BIM domain, building construction, where the level of detail is not only about geometry, shapes, but it's also about the information, the documentation. It can be about the level of detail of the properties that you are describing to define an object. It could be about many different topics. And in fact, the building industry has identified that geometry is not, you need this level of details for different type of information, not only for geometry. And there is a European standard which are defining this, the way to manage this different level of information needs in a contract. So the question is, how do we make this thing work together? And we have to check how it is today, how we can map them. For example, the level of information need for geometry and representation can be mapped to the CTGML LOD, but the other ones are not there. And we are looking at how to provide recommendation to the data spaces users on how they can use one, use the other one, map from one to the other one. That's the objective. So these are just 2 examples of places where we have to keep on working to get to enable a seamless flow of data so that your data can become useful information for your decisions.